Welcome to Network Address Translation, or NAT. This is a fundamental networking technology that you'll encounter in almost every modern network. NAT stands for Network Address Translation. It's a technique that allows multiple devices on a private network to share a single public IP address when communicating with the Internet. Think of it like a mail service where multiple apartments in a building send letters through one mailbox, but each letter is tracked to know which apartment it came from. NAT works at the gateway between your private network and the Internet, translating private addresses to public ones and back again. NAT is crucial for several reasons. First, it's cost-effective. Multiple devices can share a single public IP address, which means organizations don't need to purchase expensive public IP addresses for every device. Second, it enhances security by hiding your private IP addresses from the external Internet, making your internal network less visible to potential attackers. Third, NAT conserves IP addresses. With only 4.3 billion IP4 addresses available worldwide and billions of devices needing Internet access, NAT helps extend the life of the IP4 address system. Finally, NAT makes network management easier, allowing administrators to change internal network configurations without needing new public IP addresses. Let's walk through how NAT actually works, step by step. First, a private device on your internal network initiates a connection, sending a data packet containing its private IP address. Second, the NAT router intercepts this packet before it leaves the network. Third, the router performs address translation, replacing the private IP address with its own public IP address. Fourth, the packet travels across the Internet with the public IP address, so external networks see only the router's public address, not the internal private address. When responses come back, the NAT router uses its translation table to route the data back to the correct internal device. Security is one of the major benefits of NAT. Address concealment is the first benefit. Your internal private IP addresses remain completely hidden from external networks. Attackers on the Internet cannot directly see or target your individual devices because they only see the router's public address. Second, NAT acts as a firewall layer. It sits between your internal network and the external Internet, inspecting traffic. Third, NAT prevents attacks. Direct access attempts from outside cannot reach your individual devices. They must go through the router first, which can filter and block malicious traffic. Fourth, NAT enables traffic filtering. The router can inspect incoming traffic and decide what gets through to your network based on rules you define. This is why NAT-enabled routers are standard in home and business networks. Understanding the architecture helps clarify how NAT fits into networks. On the private side, you have multiple internal devices like computers, smartphones, and printers, each with their own private IP addresses. These are typically addresses in the ranges 192.168.0.0, 10.0.0.0, or 172.16.0.0. In the middle sits the NAT router, which acts as the gateway. It has two network interfaces, one connected to your private network and one connected to the Internet. The router performs the address translation. On the Internet side, there's the external public IP address that represents your entire network, and beyond that are external servers and the broader Internet. All traffic between the private network and Internet flows through this NAT router, which translates addresses in both directions. NAT provides several key operational benefits. First is IP conservation. The critical advantage is that multiple devices can share a single public IP address. This saves billions of addresses. Second is cost reduction. Organizations don't need to purchase multiple public IP addresses, resulting in significant savings. Third is network flexibility. You can reconfigure your internal network without affecting Internet connectivity. You can change internal addresses, add new devices, or restructure your network without needing new public addresses. Fourth is scalability. You can easily add new devices to your network without exhausting your IP pool. One public IP can support hundreds or thousands of internal devices depending on your router's capacity. These advantages make NAT an essential technology worldwide. However, NAT also has limitations. First is performance overhead. Address translation processing adds latency to network traffic because every packet must be examined and modified. Second are connectivity issues. Peer-to-peer connections can be problematic behind NAT because incoming connections are blocked by default. Inbound service access is difficult. For example, hosting a web server behind NAT requires special configuration. Third is complex configuration. Port forwarding and special traversal protocols are needed to enable inbound connections. Fourth, protocol complications. Certain protocols like ISEC and tunneling protocols fail because NAT modifies IP headers, breaking the protocol's integrity checking. Fifth is troubleshooting difficulty. End-to-end traceability is reduced, making network diagnostics harder. Sixth, application incompatibility. Real-time applications like voice over IP, video conferencing, and online gaming often struggle with NAT because they require direct connections between devices. Despite providing security benefits, NAT also has vulnerabilities. First is session hijacking. Attackers can potentially compromise NAT mapping tables to redirect traffic to themselves instead of the intended destination. Second is traffic interception. Misconfigured NAT devices might expose both internal and external traffic, allowing attackers to eavesdrop. Third is denial of service. Attackers can craft special packets that terminate legitimate connections, disrupting your network. Fourth is information leakage. The NAT specification itself has side channels that can reveal information about your network topology to sophisticated attackers. This is why NAT alone is not sufficient for security. It must be combined with firewalls, intrusion detection systems, and proper configuration to provide comprehensive protection. To secure your NAT implementation, follow these best practices. First, apply least privilege access. Configure NAT rules to provide only the minimum network access required. Don't open more ports or connections than necessary. Second, conduct regular rule auditing. Periodically review all NAT rules and remove outdated configurations that are no longer needed. Third, maintain documentation. Keep detailed records of all NAT rules and changes for audit trails and troubleshooting. Fourth, integrate firewalls. Combine NAT with stateful firewalls for comprehensive protection. The firewall inspects traffic content, not just addresses. Fifth, implement traffic monitoring. Set up logging and inspection of all inbound and outbound traffic to detect anomalies. Sixth, ensure secure configuration. Disable unnecessary services on the NAT router and use only secure protocols. Keep firmware updated with the latest security patches. In real-world networks, NAT security requires a defense-in-depth approach. First, use firewalls. Implement stateful inspection that examines all traffic entering and exiting your network. Second, deploy intrusion detection and prevention systems, or IDS and IPS, which actively detect and prevent intrusion attempts in real time. Third, use encryption. Implement TLS and SSL for secure web communications and use VPN for end-to-end encryption. Fourth, set up monitoring. Maintain continuous logging and analysis of network traffic patterns to identify suspicious behavior. Fifth, adopt a zero-trust security model. Verify every connection regardless of whether it comes from inside or outside your network. Treat every connection as potentially untrusted. Sixth, keep systems updated. Maintain current firmware and security patches on all network devices. When NAT is combined with firewalls, encryption, monitoring, and regular updates, you create a robust protection against network attacks and unauthorized access.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.